Now we look into the Terengganu essay questions. Okay, question 9. There are 3 experiments here, 1 to 3, carried out to investigate the factors affecting the rate of reactions. Okay, so let's see each experiment here. So experiment 1, okay, excess zinc granules, and then the hydrochloric acid 50 cubic centimeter, 0.5 mole per cubic decimeter. Okay, this is at the room conditions. Now excess sec 2, experiment 2, zinc granules, okay, with the addition of the substance X, also at room temperature, but here at set number 3, now the concentration of the acid is higher, okay, compared to set 1 and set 2. Okay, so the temperature all are the same at room condition. So based on the table, okay, stack 2 factors that affects the rate of reaction here. Okay, so there are 2 marks, so it is 2 points here. So point number 1, okay, so we can say set 1 and set 2, the comparison here is because of the catalyst. Okay, then another point, another factor here is the concentration, right? Okay, concentration of hydrochloric acid. Okay, so two marks here. Okay, B, write the balanced chemical equation for the reaction 1. Okay, calculate the volume of the gas released. Okay, so here for the balanced chemical equation, will be 2 points. So point 1 and 2 be equation. So let's see, the equation here is hydrochloric acid with the zinc. Okay, so zinc react with hydrochloric acid, so produce zinc chloride and hydrogen gas. So it is not balanced, so balancing another 1 mark, so this one times 2. Okay, so this is 2 marks. Now point number 3, we can find the number of mole. Okay, number of mole of the acid, so number of mole of hydrochloric acid, so we use the formula mv over 1000. Okay, so concentration is 0.5, volume is 50 over 1000, so you will get 0.025 mole. Okay, now point number 4, we need to do the mole ratio. Point number 4, mole ratio. Okay, so what to compare? So we must compare the acid given, then the question asks you to find what? To find the volume of gas, right? Volume of gas, so gas is the hydrogen gas. Okay, so 2 mole of hydrochloric acid, okay, produce 1 mole of hydrogen gas, correct? So if 0.025 mole hydrochloric acid, what do you think? 2 to 1 means half, right? So 0.0125 mole of hydrogen gas. So 0.0125 mole. Okay, so we can get the point number 5, that is finding the number volume. So volume of hydrogen gas, so we have the mole 0.0125, molar volume, so molar volume given at room condition is 24. Okay, so you will get 0.3 cubic decimeter. Okay, now C. Sketch the graph of volume of gas against time for 1 and 2 or 1 and 3. Okay, so now, okay, first we need to check, okay, the volume of the gas collected, okay, for 1 and 2. Let's say now we want to check the 1 and 2 volume concentration are the same for set 1 and 2. Just set 2, it has the catalyst of substance X, right? So meaning that set 2 will be higher rate of reaction compared to set 1, okay, because the presence of catalyst. Now meaning that, okay, if we want to compare experiment 1 and 2, okay, so the graph volume of gas unit is cubic centimeter. Okay, then the time, put in the seconds as the minute, as the unit. Okay, so set 1 and set 2, right? Okay, like say this is a set 2. Okay, set 2 higher rate, right? Okay, set 2 experiment 2. The experiment 1, okay, will be lower rate, right? Because no catalyst. Okay, so lower rate of reaction, so set 1. Okay, then if here we know the volume of the gas from the previous questions here will be 0.3, so actually equals to times 1000 is 300 lah, cubic centimeter. So meaning that here we should label it 300. Okay, so this is for experiment 1 and 2. Okay, now how about the 1 and 3? Okay, 1 and 3, so we have to double check set number 3. Okay, the concentration is double compared to the set number 1. In other words, the mole, again, the number of mole for the hydrochloric acid is mv over 1000 is double, so it will be 0.05, okay, mole. So mole ratio for the hydrogen gas will be half of it, right? Okay, so meaning that 0.025 times 24, so you get 0.6 cubic decimeter equals to 600 cubic centimeter. In other words, it will be double compared to set 1. Okay, so set 3, higher concentration, higher rate, then volume also will be double. So in other words, how is the sketch of the graph? Okay, so experiment 1 and 3. So the same, okay, volume cubic centimeter, okay, time seconds. So now let's say set 3, okay, here we put 300, another one is 600. Okay, so set 3 higher rate and then also higher volume. Okay, then set 1 lower rate, okay, lower rate and then lower volume of gas. Okay, Okay. So this is how we can sketch the graph correctly for sec 1 and sec 3. Okay, so you must know why it is like this. Okay, next D. Okay, suggest the name of the substance X used in the experiment 2. Next, compare the rate of reaction and explain by using the collision theory between the reaction 1 and 2. Another one is 1 and 3. Okay, so 10 marks here. So here, okay, first question we need to settle is the name of the catalyst. Okay, so remember, if acid we react with the metal, okay, the very common catalyst, okay, common catalyst used will be, so point 1, the catalyst or the X is copper 2 sulfate solution. Okay, you must give the name. Okay, next, compare the rate of reaction for experiment 1 and 2. So roughly is 4 to 5 points. Okay, so experiment 1 and 2. Okay, so 1 and 2 is because of the presence of catalyst, right? Okay, so what we can mention is, okay, so we directly mention the rate of reaction. Okay, so rate of reaction of experiment 2 is higher than experiment 1. Okay, so here be careful, must use the word higher. Okay, so if you use the word reject the word faster. Okay, so you cannot use the rate of reaction is faster. Okay, next, okay, because of catalyst, right? Okay, so the catalyst, okay, there is a copper 2 sulfate solution, lowers the activation energy of reaction in experiment 2. So since the activation energy is lower, so more colliding particles. Okay, so colliding particles here is what? Okay, is the not magnesium, it will be zinc, zinc atoms, and acid will be hydrogen ions can overcome the lower activation energy. Okay, then point number 4. Then point number 5, so more effective collisions between zinc atoms and hydrogen ions. Okay. That's why the rate of reaction is higher. Okay, next, experiment 1 and 3. 1 and 3 is because of this concentration. So next we are going to explain about the experiment 1 and 3. Okay, so it's point number 6. So rate of reaction of experiment 3 is higher than experiment 1. Okay, so we have to explain why. Because of the concentration, right? The concentration of hydrochloric acid in experiment 3 is higher than experiment 1. Okay, so point number 8, number of hydrogen ions per unit volume is higher in experiment 3. Okay, so point number 9. Okay, so frequency of collisions between zinc atom and hydrogen ions is higher in experiment 3. Okay, last point. So frequency of effective collisions between zinc atoms and hydrogen ions is higher in experiment 3. Okay, so that's why it has a higher rate of reaction for experiment 3. Okay, now we look into the question number 10. The following equation represent a redox reaction. So it's a silver nitrate react with the zinc, produce the zinc nitrate, and the silver is being displaced. So this is a displacement reaction actually. Okay, so now the question asked, state the name of the substance that can act as the oxidizing agent and the reducing agent. Explain your answer in terms of change in the oxidation number. Okay, so 4 marks, 4 points. Okay, so let's look into this question again. Okay, the equation. Okay, so let me rewrite the equation. So silver nitrate react with the zinc. So silver is being displaced, so it forms a zinc nitrate, and then silver is being displaced. Okay, so it's not balanced, so this one times 2, this one times 2. Okay, now we can determine the oxidation and reduction based on the oxidation number. Okay, so first we look into the silver. Again, silver nitrate. So the oxidation number for the silver nitrate, silver here is positive 1. Okay, nitrate we can assume it is as 1, so charge is negative 1. Zinc is the metal, right? So metal is 0. zinc nitrate, so zinc now becomes a zinc ion, positive 2, nitrate assume as 1, negative 1, silver becomes 0. Okay, so based on the change in oxidation number, so let's see. Silver it changed from positive 1 to 0, correct? So meaning that positive 1 to 0 decrease in oxidation number, so it is undergoes reduction. Okay, so reduction it becomes the oxidizing agent. Okay, because in the decrease in the oxidation number. Then as nitrate we can see negative 1, here also negative 1, so no change in oxidation number. For zinc, yes, it undergoes the oxidation change in oxidation number, change from 0 to positive 2, so increase, right, increase in oxidation number, so it is oxidation, meaning that it is a reducing agent. Okay, so we can write, okay, 0.1 oxidizing agent is this undergoes reduction, so silver nitrate. Okay, or you can write silver ions. Okay, so can we write the formula? No, because the question says that the name, so here is a reject formula. Now point number 2, okay, reducing agent is a zinc. Okay, zinc. So point number 3, okay, why it is undergoes oxidation, silver as an oxidizing agent. Okay, because silver oxidation number of silver, okay, decreases from positive 1 to 0. Okay, then point number 4, oxidation number of zinc increases from 0 to positive 2. Okay, so these are the 4 points for these 4 marks. Okay, next. Okay, diagram shows apparatus to investigate the electrolysis of a process in the cell 1 and cell 2 using the carbon electrodes for both cells. So here we can see the electrolyte used is hydrochloric acid. Concentration is 0.01 mole per cubic decimeter. Also for the Sec2, the hydrochloric acid used is concentrated 2 mole per cubic decimeter. Okay, so we roughly go through these 2 experiments. Okay, so first we list out all the ions. Hydrochloric acid, we have hydrogen ions and then the chloride ions. So water, hydrogen and hydroxide. Okay, so in this case, okay, hydrogen no need to choose, only one, but these 2, chloride and hydroxide, only one will be selectively discharged. If dilute concentration, dilute electrolytes, we will choose the hydroxide to be selectively discharged. Okay, at the anode there, so you produce oxygen gas. Okay, then for this set number 2, okay, same hydrogen ions and chloride ions. solution, we have hydrogen ions and hydroxide ions. Okay, but in this case, if the concentration is higher, which is more than 0.1 mole per cubic decimeter, the ions that will be selectively discharged is the chloride. Okay, chloride ions. So in other words, you produce the chlorine gas at the anode there. Okay, here also. Okay. So for the higher concentration, the affected ions there will be chloride, iodide, or bromide. Okay, so only these three ions, if they are concentrated, they will be selectively discharged. Okay, now let's see what is the question. Okay, it shows the standard potential electrodes: hydrogen, oxygen, hydrogen ions, hydroxide ions, and then the chloride ions. Okay, so based on the cell 1, okay, state the name of the product formed at the cathode and an anode. Okay, so for set 1, so at anode undergoes oxidation, right? So hydrogen, hydroxide ions will be selectively discharged, right? Okay, at the anode. Okay, because E naught value is less positive. Okay, so if hydroxide ions is selectively discharged, the product will be oxygen gas, right? But you need to use the name. Okay, write the name. So we must write the name. Okay, so it will be oxygen gas. Okay, meanwhile at the cathode only one, that is the hydrogen, so hydrogen gas. Okay, so 2 marks. Now number 2, okay, the product collected at the anode in cell 1 and cell 2 are different. Explain your answer in terms of selectively discharge of the ions. Okay, so 6 marks here. So let's see. So in set 1, okay, we can explain one by one slowly. In set 1, okay, products at anode is oxygen. Okay, why? Because hydroxide ions is selectively discharged. Okay, because the E naught value of hydroxide is less positive, correct? Less positive than E naught value of chloride ions. So it will be undergoes oxidation. Okay. Now in set 2, this is in set 1. Now in set 2, okay, product at anode is chlorine. Okay, chlorine. Chlorine gas. Okay, so chloride ions is selectively discharged. Okay, because the concentration of chloride ions is higher than hydroxide ions. Okay, yeah. So it is selectively discharged. Okay, so altogether 6 marks. This is number 2. Okay, now number 3. Okay, write the half equation of the anode for cell 1 and cell 2. Okay, so cell 1 at the anode na. So the half equation we can refer to here lah, because we select the hydroxide, right, for set 1. Okay, so will be for OH, we just copy from the anode cell there. Okay, so O2 plus 2H2O, lost 4 electrons. Okay, for set 2 anode, so it's chloride, right? So 2 chloride, okay, produce chlorine by lost 2 electrons. Okay, so this is for number 3. Okay, now C. The production of the iron in the industry through the reaction between the iron ore and coke is shown in the diagrams below. Okay, so first determine the oxidation number for iron in the compound of iron 2 oxide and state the name of the compound according to the IUPAC nomenclature. Okay, so for this question, okay, C1, so we can first calculate the oxidation number for iron. So Fe2O3. So what is the oxidation number? So we replace with X. There are 2X plus oxygen is oxide is -2, it has 3. So equals to 0 because nothing, no charge. So 2X minus 6 equals to 0. So 2X positive 6. So X will be positive 3. So in other words, the oxidation number for the iron is positive 3. Okay, now how about this name? The name. So since the oxidation number is 3, so it will be iron 3 oxide. Okay. Now question number 2. The factory is able to process 320 kilogram ore a day by using excess carbon. So calculate the mass of the iron produced in a day. So in 1 day, so 4 marks. So how do we do this calculation? Okay, now, okay, first we can calculate the number of mole, right? Okay, so first 320 kilogram equals to 320,000, right, gram. Okay, so we can find the number of mole of iron 2 oxide. So the mass here is 320 100,000, okay, divided by iron 3 hydroxide. Okay, sorry, iron 3 oxide. So iron 3 oxide, we use the AR given, so we need to calculate. So we total out iron 3 oxide is 160. So you get this 2000 mole. Okay, so 2000 mole. Let's see the mole ratio. Okay, mole ratio. Okay, so 2 mole of iron 3 oxide produce, okay, 4 mole of iron. Okay, so if 2000 mole of iron 3 oxide produce double, so it's 4000 mole of iron. Okay, so the mass, okay, mass of the iron produced more is 4000 more times iron Fe. So Fe is 56. Okay, so you will get is 224,100,000 gram, or equivalent to 224 kilogram. Okay, so this is a mass of the iron will be produced in a day. Okay, question 11. Okay, let's see. Diagram shows the container P and container Q containing the acid HX and HY acid. Both acids are monoprotic acid. So the clue here is monoprotic acid. Produce one more of hydrogen ions. Okay, now we see hydrogen ions in the HX acid all are ionized completely. So meaning that we can denote this is a strong monoprotic acid. So in our syllabus we have only 2, hydrochloric acid or nitric acid. Okay, then for this HY, you see not all are ionized, right? So still got some exist as molecules form. So meaning that this one is a weak monoprotic acid. Okay, so the only example we always use is ethanoic acid. Okay, CH3COOH. Okay, now let's see the questions. Okay, table shows 2 neutralization reaction involve, okay, sodium hydroxide solution with HX and with HY. So the heat of neutralization given, okay, this one is a strong acid with strong alkali, 57 kilojoule per mole. Heat is released, but this one is a weak, okay, HY is a weak acid, so that's why it's less than 57 kilojoule per mole. Heat is released. Okay, now first question, okay, what is the meaning of heat of reaction? Okay, so A, so heat released when 1 mole of water is formed, okay, is formed, okay, from neutralization of acid and alkali. Okay, so this is the definition. Now B, state one suitable example. Okay, so now I give the example already. So HX is hydrochloric acid or nitric acid. Okay, also accept the name of the acid. Okay, HY says ethanoic acid or the name of it, ethanoic acid. Okay, so C, based on the reaction 1, calculate the highest temperature of the mixture for the reaction. Okay, so here we know that in set 1, okay, given to you, set 1 delta H is negative, heat is released, kilojoule per mole. Okay, yeah. So now we can use the formula. Okay, we have Q delta H equals to the Q over the mole, correct? So the mole here, okay, first we calculate the number of mole first. Okay, so mole of the acid, right? So acid is, we use the mv over 1000. So m is 1, v is 100 over 1000. So you get 0.1 mole. 0.1 mole. So we replace in delta H is 57. Q you need to find, mole is 0.1. Okay, then we can find the Q. Q is 57 times 0.1, so equals to 5.7 kilojoule or 5700 joule. Okay, and then if we know the Q already, so we can replace in Q equals to mc theta. So Q is 5700, m is 200, because the volume of the acid and alkali is 100 each, so total up 4.2. okay, times the theta. Okay, so we can use the find the theta is 6.78 degrees Celsius. Okay, the highest temperature here will be 6.78 degrees Celsius. Okay, next, compare the heat of neutralization in a reaction 1 and reaction 2. Okay, so for D, point number 1. Okay, so heat of neutralization for, okay, for here we can see reaction 1 is higher, right? Okay, compared to reaction 2. Okay, so for reaction 1 is higher than reaction 2. Okay, why? You need to explain. So point number 2. Okay, HX is a strong acid that ionize completely in water to produce hydrogen ions, right? Okay, now point number 3. Okay, HY is a weak acid that ionize partially, okay, in water to produce hydrogen ions. Okay, so point number 4. Okay, so some heat release okay, during neutralization, okay, in reaction 2 is absorbed, okay, by HY molecules to ionize completely. Okay, okay, So here are the 4 main points. Okay, but here already is given is 5 marks. Okay, maybe somewhere here it will be given extra 1 mark. Okay, for strong and weak acid here. Okay, ionized completely, these are ionized partially, then produce hydrogen ions, there will be another extra mark. Okay, so last question, E. Okay, table shows the fuel of combustion for ethanol and kerosene. Okay, now have a look here, the heat of combustion. Okay, kerosene are much more higher compared to the ethanol. Okay, now based on the table, choose one fuel that is the best terms of fuel value and then effects on the environment. So justify your answers, your choice. So molar mass given for alcohol is ethanol is 46 gram per mole, kerosene is 170 gram per mole. Okay, so 8 marks here. So for this question, okay, so better for us to calculate for the fuel value. Another one is effect on the environment. We need to calculate the percentage of carbon actually. Okay, so first we calculate the fuel value first. Okay, fuel value. So we calculate. Okay, so fuel value, the formula is the heat of combustion. Okay, divide by the molar mass. Okay, so first we calculate for ethanol. So the heat of combustion is 1380 divided by the molar mass is 46. Okay, so you will get 30 kilojoule per gram. Okay, then how about the kerosene? So it's 6290 kilojoule per mole. Molar mass is 170. So you get is 37.0 okay kilojoule per gram. Okay, now in terms of this fuel value, okay, calculated, so we can say fuel okay, so we can say kerosene is better fuel, okay, in terms of fuel value because it has higher fuel value compare to ethanol. Okay, better fuel, I think we cancel this. Okay, because it has higher fuel value compared to ethanol. Okay, so it's a correct way to explain the answer. Okay, next, in terms of effects on the environment. Okay, so for environment, okay, so we also can calculate for ethanol C2H5OH. Okay, so we need to calculate the percentage of carbon So for this carbon you have 2, okay, so 2, carbon is 12, so overall is 46, right? Okay, 10 times 100%, so you get 52.17% of the percentage of carbon. You need to find the percentage of carbon in the compounds there. Then for the kerosene, okay, so there are 12 carbon, so total up is 170 times 100%, so you get is 84.17%. okay, so in other words, here we can say if percentage of carbon in the fuel is lower, is better for the environment, correct? So ethanol is the best fuel, okay, in terms of effect on environment, okay, because the percentage of carbon per molecule is lower, okay, so it produces less soot, okay, and less pollution to environment. Yeah, okay, so this is how we justify, okay, for the fuel value, okay, based on the fuel value and then the effect on the environment, okay. So this one are the choices. Okay, so that's all for the part B, the second part, the essay question on the MRSM, okay, trial papers. Okay, thank you very much.